So a few more things about what we've done so far. If we have collinear or coplanar, what does that word co, or the prefix co mean? Same, or like together with? That's what co means. So if we're talking about collinear, bless you. If we're talking about collinear, we're talking about on the same what? Line. And then if we're talking about coplanar, we're talking about on the same plane. So, bless you. Other real-world examples of collinear or coplanar, I can think of a coplanar right away. I can think of this because my children are slobs. I love them, but they make messes. So when we eat dinner, here's my dinner table. This is what my dinner table looks like every day after we eat. Yeah, because and my floor looks like that too. Cause they just anyway, so here's an example of, is this collinear or coplanar? What do you think? Lynn, what do you think? Coplanar. We've got a bunch of dots, a bunch of points on a flat surface. Coplanar. Collinear. Where could we give an example from real life of like a line and a bunch of points that are on that same line? Can you think of anything? All right, not everybody does this, but some people do. Oh my gosh, I am such a good artist. If you say so. Here's my collinear. Oh, it's kind of off the screen there. What do you think? Is that a good collinear example? Like Christmas lights on a string? I don't know. Collinear. Alright. And then the last thing is just reviewing rays. When we name rays, that could be tricky. Remember, we have to first identify what part of the ray comes first. Bless you. What part of the ray comes first? The end point. And that's weird because it's the end, but you list it first. But it's the end point. The end point comes first. Oh no. So we list the end point first. Then you follow along the direction of the ray towards the arrow. So we start at Q, we go towards the arrow, and then we name any point that it passes through from there. So this ray right here would be QP. And then please list it as the end point on the left side. And it always points to the right, QP. Okay, naming segments and rays. So that got cut off. That should say EF. Did yours get cut off too, or just mine? Yours got cut off too. That should say line EF. It should say line E. Nope, I'm lying. That should say ray EF. I didn't even remember. It should say ray EF. And then ray FE form a line. Are they opposite rays? So here's a line we can try. Here's E. That's E. Here's F. And they form a line. If I do E to F, here's E to F. And if we do F to E, are these opposite rays? Opposite rays share the same endpoint and then form the line. So these are sharing two different endpoints. They overlap. That's not what opposite rays are. So opposite rays share the same endpoint. Opposite rays share the same endpoint. Fill in the blank. The intersection of two lines is a, oh gosh, I forget. Let's draw two lines. Here's two lines. Where do they overlap? At what kind of geometric figure? Cameron? A point. When we cross two lines, they make a point. The intersection of two planes is a line. That's like the ceiling and the wall, or the two walls that come together in the classroom. Here we go, I'm going to try to draw two walls in a classroom. The two walls that come together, it makes a line. That was pretty good, two walls there. You just got to like build yourself up here. I'm a good drawer. I'm a good artist, I mean. Okay, now we're starting new stuff. The intersection of two sets is the set of elements in which are in both sets. Intersection is something that has to be in both. Intersection, right? So when we talk about the intersection of this wall and this wall, what's in both? The corner of the room. That's the part that's in both. That's the intersection. The word union is like joining two things together. So the union of two sets would be anything that's in either set. So if I'm talking about the union of my, oh gosh, how do you describe this? That wall, the one that's by the door, the union of this wall and the union of the wall that has the board on it, the union is going to be both walls together. Like it's going to include everything. Intersection, we denote this with a symbol. The intersection symbol looks like this. Kind of weird. The union symbol looks like this. Alright, so I put the two symbols in there. I was taught different ways of remembering these. How can we remember that the union symbol, I know you guys can come up with this, how can we remember the union symbol looks like that? Because it looks like a U. Now the intersection, there's different ways you could remember this one. Intersection is what they both have, and a lot of times we use the word and when we talk about intersection, and I'm going to use that word and as well. And right in the middle of the word and is that symbol that makes the intersection. There's the upside down U. The N. It's not an N, but it kind of looks like an N if you think about it. Close enough. So intersection, only what the sets share in common. It's what they have in common. It's what they share. These elements must appear in both sets. So for intersection, whatever it is has to be in both sets. Have you guys done Venn diagrams before? Venn diagrams? So I'll show you what I'm talking about if you forget. Where's the Venn diagram where you have like a and then that. And then the and would be what they both have in common. That's the intersection. The or would be everything. Okay, so the union, which that one's the or. To unite, we're bringing it all together. All of the elements in either set. And then again, I said the word or. This item could be in both sets. It's okay if it's in both sets already. Oh no. My Christmas lights, they bled through the paper. Oh well. No more Sharpies. So the intersection and unions with numbers. This is where it's pretty easy to figure out. It gets a little harder when we talk about pictures. But the intersection and union with numbers. If we're talking about B and C, Which symbol is this? Is this the and or the or? Is this the union or the intersection? Which one's this one? Intersection. This is the and. So we're looking at B and C. So up here B has 0, 1, 2. C has 1, 2, 3, 4, 5. Intersection means and. What do they both have in common? What numbers? 1 and 2, and that's it. So we create fancy brackets, just like these have, fancy brackets, and we list 1, then 2 in numerical order and close the fancy bracket. That is the intersection. Question B says B, and then that's which symbol? It's the union, which means or. C. So that means we put together everything in B and everything in C. So let's look at B and C. What numbers should be in our new set of the union of B and C? 0. Then what? 1. Then what? Okay, hold on. There's 2 ones. Should I list 1 twice? No. If it's in it, it's in it. You don't have to repeat. It doesn't matter how many times. It's in there. So we just list 1, and then we list a 2, and then a 3, and then a 4, and then a 5. So that are the numbers in either set. Okay, so how about A intersection B? A and B. A and B. The number 0? Is that what you meant? You didn't mean none of them. You meant the number 0. Okay. You guys see how they both have the number 0 in common? Are there any other common numbers besides the number 0? Nope. Okay. Question D. A or B. A union B. That means you list everything in order. -4, -3, -2, -1, 0, 1, 2. Okay, look at E. Question E says B what D? And, or intersection? Yeah. Now what? What do they have in common? What do B 0, 1, 2 and D 4, 5, 6, 7, 8, 9, 10 have in common? Nothing. So there is a symbol that means they don't have anything in common. There's 2 ways we could write it. You could either write a fancy bracket and close the fancy bracket. That means empty set. That means nothing in common. And then there's another symbol which I feel like maybe you've seen before because I see people use it even though they use it wrong. This also means nothing in common. I really prefer this one because it'll just keep it the same. Like all of them have fancy brackets. That one just doesn't have anything inside of its brackets. Alright, and then the last one, B or D. So B or D. We're doing all of them. So where's B? 0, 1, 2, 4, 5, 6, 7, 8, 9, 10. Alright. And then the very last example we're doing today is example 6, intersections and unions with geometry. Use the diagram to the right to answer the question. We've got segment AB, union, just kidding, intersection, BC. So and, this one's and. I have to write the and down because then I forget what I'm doing. AB and BC. So we're going to look at this picture. AB is here. And BC here, what do they have in common? Simon? What B? Point B, right. So when we talk about and, we're talking about what they share, where they intersect. And then we've got union, EC, union EA. EC, union EA. Let's see, EC here, and it's array. EC goes this way. And then EA that way. What happens when we do or, when we do put them both together? They share, they go together, they unite. What happens when they unite? What does this make? Who said a line? Good, it makes a line. We need to name that line. Any ideas? Here, somebody raise their hand, 'cause I can hear but I can't hear. Only one person, 2 people can name a line in here. Alex, can you name the line? Give me a line. AC? Is that the only acceptable answer? No. Jay Supreme, can you give me a different way of naming that same line? What was the second one you said? I heard the first one, but that one was... Line AC. Oh, you mean with words? Yeah. Oh, yeah, sure. How about using different letters? John, can you give me a different